Hello there, and welcome to this video on graphing and rate of change. In this video, we're going to be given some information about a graph, and we're going to use that in order to draw the graph. So in point number 1 here, it says use slope to graph a line. So if we have this information, if you know one point on the line, you can use the slope to find other points that are on the line. Because if I know, say, this point right here, and then I know my slope, and remember our slope was just equal to our rise over our run, and we often use the letter M to represent slope. So we can see we are rising and then running, rising and then running. So if I know the slope, I can get to the next point, and then I'll do another slope, a rise and a run, get to the next point, rise and run, and you could just keep continuing this process. If you wanted to go kind of backwards, what you'd have to do is you'd have to run the other way, and then rather than rise, you fall. Okay, so it'd be run the other way and then fall. So you could do it that way too. So in this first example, it says the point -3 and 2 is on a line that has a slope of -3/4. So that right there, that is our M, and remember M is slope. So that's the rise over the run. So in this case, we are going to rise -3, and then we are going to run 4. So really, if you rise -3, what that means is you're going to actually fall 3, and then we're going to run 4. So when I go to graph this one, because I'm falling, or because it has a negative slope, it's going to be going downwards. So our steps to doing this, and we're just going to go through and kind of look at the first one, and then after we're going to do some examples. So step 1 is plot the point. So the point -3 and 2, I'm just going to label that. This is X, and then our second point is Y, right? This is our X-axis, and then this is our Y-axis. So you're going to go to the point -3 and 2, so that's going to be -3, and then up 2, so that's that point right there. And then, once we have that, so we're done step 1. Step 2, we're going to plot the point, and then count the rise and the run. So we've gotten our point right here. Then what we need to do is rise and then run. So our rise was actually a fall of 3, so we're going to go down 1, 2, 3, and then we're going to run 4. 1, 2, 3, 4. So that was rise -3, and then we ran over 4. And then this would just continue. You'd fall another 3, and then move over another 4. And then you can see we get all of these points on our graph. So steps 2 and 3 would be done. And then what we're going to do, our last step, is draw a line through the points. So we take our ruler, make sure you're always using a ruler, and then draw your line through your points. So moving from there, we're going to get into some examples here now. So the first one, it says draw a graph for the following question. So it says the slope is 2/3. So I'm just going to put over here our slope, which is M, is 2/3. So that means we're going to rise 2, and then we're going to run 3. And then we're given the point 2 and 1. And I'm just going to label that. That's X, and that's Y. So our step number 1 from before was plot the point. So that point 2 and 1, we're going to plot that. So I'm going to have to go over 1, 2, and then up 1. So right there is where I'm going to have my point. So we'll plot that. So step 1 is done. In step 2, what we were going to do was use the slope to find another point. So as we had said, the slope was 2/3, so that meant we were going to rise 2 and then run 3. So I'm going to rise 2, 1, 2. So there's a rise of 2. And then we're going to run 3. 1, 2, 3. And then that is where we're going to plot our next point. So I've kind of combined from the previous page, step 2 and 3. I'm already plotting this point right here. Okay, and you can continue to do that. If you wanted to do it another time, you could rise another, say, 2, and then run another 3, and then you'd get another point. And you could keep doing this, but really you only need 2 points to do this. So then we get to step 3, and step 3 was to draw a line through those points. So you're going to take your ruler, set it on your points, and then draw your line going through your points. And then at the end of your line, what you can do is put arrows on that. Those arrows signify that the line just keeps going and going and going. So we're going to do another one like that now, number 2 here. And if you guys want to maybe try this one first, you can pause the video and try to do this one. So step number 1, we're going to plot our point, and this was our point, 1 and -3. So I'm going to be over 1, and then I'm going to be down 3. So that brings me to this point right here. Then to get to our next point, we're going to have to use our slope. So use our slope to find another point. And our slope was this right here, -1/4. So I'm just going to put that here, -1/4. So that means we are going to rise -1, and then we are going to run 4. And again, if we're rising a negative amount, that means we're actually going to fall. So we're going to fall 1, and then we're going to run over 4. And then that gets us to this point right here, so we can plot that point. If we wanted to do it again, we can do another fall of 1 and then another run of 4. So we get another point right there. And then lastly, step 3, draw a line going through our points. So take your ruler, again, gotta use a ruler, and then draw your line going through your points. And then at the end of the line, make sure that you put your 2 arrows. So that was our last example of that type. This is going to bring us to the last thing we're going to look at. And this is point number 2 here. It says slope as a rate of change. So slope, really what slope is a rate of change. It's the rise being divided by the run, and each of those 2 things are different measurements. So in this case, you could have the rate of change is, remember this triangle, it meant change in. So this is the change in D, and D is going to represent distance. So this means change in distance. And then in the denominator there, change in T, that's going to represent the change in time. So if I tried to ask you what this represents, if you had a change in distance being divided by a change in time, do you know what that represents? And if that question's a little bit hard to answer, what if I gave you units? What if I said the change in distance was kilometers and the time was hours? What if you had a kilometer per hour as your units? So that might be a little bit easier now. If you see a kilometer per hour, you're probably thinking that has to do with speed, and you would be correct. So kilometer per hour, that would be a speed. So in this case, in this example, we're going to be trying to find the speed. So it says the graph shows the approximate times at the 1,000 meter mark and at the 1,500 meter mark. So that is right here and right here. So this is 1,000 meters. We went up 1,000 meters, and that took us 205, and this is seconds. And then at the 1,500 meter mark, we're right here, and that was at 297, again, seconds. So what it's asking us to do, it says determine the average rate of change for this portion of the race. So we're going to have to start with the rate of change, and the rate of change, all the rate of change is slope. And we knew from before that slope, right, we used the letter m, but we had this formula. It was y2 minus y1 divided by x2 minus x1. And as long as I have 2 points, like these 2 points here, I can figure out what the slope is. So I'm going to go to my points and I'm going to label them. Again, it doesn't matter how you label them. I'll call this one x1, y1, and I'll call this one x2, y2. You could have labeled it the other way and you'll still get the same thing. So plugging into our formula down here at the bottom, y2 is 1,500, and then minus y1 is 1,000, and that's all being divided by x2 we labeled was 297. Subtract x1, which was 205. And then once we have that, we can just start to simplify this. So if we subtract in the numerator there, 1500 subtract 1000, you're going to get 500. In the denominator, 297 subtract 205 is 92. And I'm just going to add something onto this. These units up here, these were meters. And these ones down in the denominator, those were seconds. So what we have right now is a meter being divided by a second. And when we do that division, 500 divided by 92, you're going to get 5.4347. And then there's some decimals after that. And then our units were meters per second. Meters per second. So a meter per second, that is speed again. Okay, so what we just found, this slope, what it represents is speed. So depending on what you have for units, that's gonna tell you what your slope or what your rate of change represents. So if you maybe had something like this, centimeters per year, that can mean a lot of different things. If it was in the context of someone's height, that could be maybe how many centimeters they're growing per year. So the rate of change would be their growth in height. So that was our last example. The only thing we got left here is our homework questions.